Hello friends, myself Parag J Tarwadi. I am from MTech Mechatronics SMBS division. My registration number is 13MMT1054. Today I am going to present seminar on multiplexers and this multiplexer. First of all, we will see the contents for the seminar. First we will see the multiplexer, that is basic functioning of multiplexer, block diagram of multiplexer and how it will be implemented. Then we will see uses and application of multiplexer. Then we will going further for demultiplexers. In demultiplexers we will see the uses and applications, also the basic functioning, block diagram and how multiplexer is used in industrial environment we will see. First of all, we will see multiplexer. Multiplexer is nothing but a digital switch that has a multiple inputs and single outputs. Means there is a multiple sources which are coming to the input, and we will give only a single output as destination. For this, the select lines are used to determine which input is present at the output. Means it depends on the select lines. That is where switching action in input we will have the switch, and by controlling that control of the switch is depends on the select lines. There are different types of multiplexer or mux. In the multiplexer is formally known as mux. It having different types, that is 2 to 1, 4 to 1, 8 to 1, 16 to 1. Means it is also called as 2 to 1, 4 to 1, 8 to 1 or 16 to 1 multiplexer. There is the 1, 2, 3, 4 are different select lines for particular mux. Next we will see a multiplexer has n control inputs, 2 to n data outputs and 1 output. Means at the source we will see in block diagram there is one equation is there, 2 to n, and select lines are n. Means it depends on select lines how many inputs should be present, or in how many inputs are present. On the basis of that we will select the select lines or control lines. If n is equal to 2 means 2 to 2 means 4, that is input lines are 4 or select lines are 2. If 2 to 3 means 2 to 3 is 8, means 8 input lines, and for 3 we will see 3 select lines, and at the output destination we will get a single input present. It is based on the select lines. Next we will see, this is the one of the diagram for 2 to 1 or 2 to 1 multiplexer. Here I0, I1 are data inputs, A is the control input and Z is the output. Here in second diagram we will see one switch is showing there for I0 and I1, and A is connected to that switch as a control input. On the basis of that, which input should be present at the output will be decided. The complete output equation is given below, that is Z is equal to A dash dot I0 plus A dot I1. Means at this position it is connected to I0, it is A dash, and if it is connected to I1 it is A. So combined at the output we will see the multiplication and addition factor should be present for output that is Z. Next we will see here we will show that 4 to 1 multiplexer. There are 4 data inputs, I0, I1, I2, I3, 2 control inputs, that is A and B. B is the least significant bit and A is the most significant bit. Here if we will get 3 inputs, control inputs means 3 inputs, and then data inputs will be 8. Then for 3 inputs we will give, if A, B, C, then A will be the MSB and C will be the LSB. It is different and it is changes according to the given inputs. Also we will see here one truth table is there. If 0, 0, A and B are both are 0, then I0 should be presented at the Z as output. If A and B, that is 0 and 1, means A is low and B is high, then Z is equal to I1 should be present there. If A is 1, B is 0, means A is high, B is 0, then Z is equal to I2 will be there. And if both are high, that is A and B both are 1, then I3 will be there. Means we will see on the truth table, it is clearly shown that whatever the controlling action done by A and B, the particular input will be present at output. For that the combined equation showed there, that is Z is equal to A dash B dash I0 plus A dash B I1 plus AB dash I2 plus AB I3. Next, this is the internal diagram for 4 to 1 multiplexer. Here we will see 4 AND gates and 1 OR gate. These 4 AND gates are provided their output to the OR gate, and also there are 2 select inputs A and B. For that 2 AND gates, 2 NOT gates are there to change the situation or circuit. So we will see as in the last equation, that is a into b dash, a dash into b dash into I0, means if I0 is present, so I0 a and b particular inputs are get multiplied and then giving it to the OR gate. OR gate what does? OR gate gives does all the addition of given inputs and gives the output in the format the given equation, that is we will see here z is equal to a dash b dash into I0 plus a dash b I1 plus ab dash I2 plus ab I3. So the basic function in multiplexer of OR gate to add all the inputs and give the particular output. Secondly, we use a small diagram for the same, that is the mux is present, I0, I1, I2, I3 are inputs, and depends on A and B control inputs, we will get the output at Y. These are the waveforms for multiplexer. There is I0, I1, I2, I3, 4 input data. Then A, B are select inputs and Y is the output data. Here we will see when I0, when D0, D1, D2, D3, then D0, D1, D2, D3, how simultaneously they present on the at the output. Means first we will see at low side, means A and B both are 0, D0 should be present. If A is high, B is low, then D1 is present. If A is low, B1 is high, B is high, then D2 is present, and at the same time last is the A1, A is high, B is high, D3 should be present. Here D0, D1, D3 are nothing but same, I0, I1, I2, I3, that is input data. So in second we will see the same thing. Here we saw A is at low, B is low, D0, same cycle will be continuous as the previous. Next we will see the one typical application of multiplexer. There are multiple sources are as the input source, there is two selectors are there and a single destination will be there. Here we will see four application or four sources are given as the input. On the base of data is 2:2, means 2 are the control n, 2 is the n, that is n is equal to 2, that 2 will be the number of select lines. So here A and B, 2 select lines are there, means MP3 player, laptop, digital satellite or digital cable TV, satellite simultaneously connected to the surround sound system based on these select lines. Means when A and B both are 0, MP3 player is selected to sound system. Then if 0 and 1, B is 0, A is 1, then laptop sound card will be connected to surround sound system. If B is 1, 0, A is low or 0, then digital satellite will be connected to surround sound system. And if both are 1, means both are high, then digital cable TV is connected to surround sound system. It is not basically means you also change the order of the system. It only thinks the assign the input as the addressing or whatever the selector selects the input. These are the uses of multiplexer used in data communication for several computers to communicate over one line. Means even in we see bus topology or in other topologies, simultaneously several computer systems are communicate with one master system or master computer system over one line, single line. For that, in a single communication way or a single way communication, this type of multiplexer is used. Then also used in radio to select one channel from many. Then used to route data within a computer and used for function the network. One more example I want to tell here. In telephone industry or in telephone line, we will see there are lots of cables are there, and if a single user having multiple input calls, it is decided on the basics of only mux. There is a multiplexer is used for that purpose. Next we will see demultiplexer. What is demultiplexer? It is formally known as demux. Demux is a completely opposite to multiplexer or mux. It is a digital switch which a single input and multiple output. Means a single source is there and multiple destinations will be there. The select lines determine which output input is connected to. Means here also select lines are there to decide which output should be connected to input. There are different or several types of demux type, that is 1 to 2, 1 to 4, 1 to 8 and 1 to 16. Also 1, 2, 3, 4 are different select lines are there. Here we will see how the outputs or how the inputs are related to outputs and how select lines referred or how select lines are calculated from outputs or how outputs will be calculated if select lines are there. That is n is the control input or select lines, 1 is the data input and 2:n is the output. Same thing is here. If I have two select lines, then my output will be 2:2, that is 4. If I have select lines 3, then I have 2 raised to 3, that is 8 output lines. Then this is the internal diagram for demultiplexer, that is 1 to 4 demultiplexer. Here X is a single input, and D0, D1, D2, D3 are 4 outputs. Here also 2 select switch, that is A and B, which having 2 NOT gates. But here one difference is there in mults and demux, that is in mux we will see OR gate is there to add the all equation, all the inputs. But in here we want separate outputs, so here we didn't need any OR gate. The same thing we will explain from this given truth table, that is if 0 0 is there, if 0 1 is there in at select line, which will be presented at the output. Then this is the same as a multiplexer, that is this is the waveform for 1:4 demultiplexer. Here we will see if select lines S0 is low, S1 is low, then D0 will be present. Then same, if S0 is high, S1 is low, then D1 is present. Simultaneously single inputs are present according to the given input or given control line or given select input line. Then here also I will given one application, typical application for demux. Here is a single source is used as a computer, and in multiple destination we will use several things, that is black and white laser printer, fax machine, color inkjet printer, and plain plotter. It is not necessary to have all these 4 in the same order. We will change the logical order as well as in the truth table of select lines. Here 2 select lines are there. We will see 4 outputs, that is 4 means 2 raised to 2, that is 2, n is equal to 2. So we have 2 select lines. Let's we see if both are low, B and A, then black and white laser printer is selected. If only A is high and B is low, then fax machine is selected. If B is high and A is low, then color inkjet printer is selected. And 1 and 1 means both are high, then pen plotter will be selected. Next we will see seeing is not always believing. Means here I am going to explain how in digital world the multiplexer and demultiplexer is advantageous than previous one. Here you will see our lives are filled with electronic signs that display the time, temperature, or ball game score. However, what we see is not always what is really happening. In fact, for most displays, the individual display segments are cycled through so that only one display is on at any given time. Means here we will see at a single time there is if several things are there, then only single display will be on at the same time. The cycle speed is so fast that the human eye perceives that all segments are on. Next we will see one example that in previous systems there is if one simple message we want to send to several 7 segment display, we will see the circuit to the right uses 4 7 segment displays to display the word CIAO. In this circuit, all displays are continuously illuminated, each displaying one letter in the word. Here we will see simultaneously single means first C, then I, then A, then O, again C, I, A. Simultaneous display, and it is continuously working. So according to human eyes perfection, he is easily D without any fluctuation on the display. Through this method works, it is very insufficient use of power because simultaneously all displays are going on. And to illuminate the simple message CIO, in this way 18 segments will be continuously on, so power will be more consumed, and these previous systems are so much costly and all these things. So we will go to your digital switches in multiplexer and all. Here we will see multiplex display segments in which manual selector will be there, 2 selectors are there, key A and key B. One demultiplexer is there, then all are there outputs, multiple outputs will be multiplex at several one point to give the different outputs. In this circuit, the display segments are multiplex, meaning that only one display is on a time. In last system, you will see simultaneously all system will be on, but here you will see only one display is on at a time. To display the entire world, the displays must be demultiplex using 1:4 multiplex, because these 4 7 segment displays, so we will use 1 to 4 demux. In this example, the select lines that control the demux are connected to 2 switches. I already told A and B. There are 4 7 segment displays, mean the 2 raised to 2, that is n is equal to 2, so 2 select lines are there, and you must toggle 0 0 0 1 1 0 1 1 to see the entire message simultaneously. But according to this, the one more disadvantage in this is not a practical system, it having some its own disadvantages. We will see this complete design, which is the original error-free system. Here, instead of using two switches, it uses two comparators, 2-bit comparators, that is 74LS74D and 74LS74D. Here we will see 5-volt supply is given to the both. It compares the input and gives it operates simultaneously demugs, and simultaneously CIAO pattern will be we will get. So this complete design is advantageous over all last designs. So today we will finally see several things like what is multiplexer, how it works, then different types of multiplexer, then uses of multiplexer, application of multiplexer, then how multiplexer used in telephone industry. Then we will see demultiplexer, what is the basic function of demultiplexer, what is block diagram of multiplexer, how demultiplexer is different from multiplexer, then their application, their uses, and in the last we will see in previously what system used to display the 7 segment display. Then we will give one not practical, but it is one of the advantages to the previous system approach, and in the last the complete system design we will show. In this we will see the different how using comparator instead of switches, how the practical system will be worked. So thank you, this is my presentation.